Hello everyone, and welcome to Coding with Tom. If you liked this video, please click like, subscribe, and hit the notification bell. This is the second video of my series on how to build a chatbot with C#, Blazor, and the Azure OpenAI service. In the previous video, we made a chatbot that could answer questions using the ChatGPT 3.5 large language model. But what if we want to create a chatbot that can answer questions based on our own company data? Our company data is not part of the training data for the GPT 3.5 model, so how can we make it work? We can use Azure Cognitive Search, a vector database, to store our data in an index. Azure Cognitive Search can find relevant documents based on word and phrase similarity. When we combine these documents with the question to produce a response, this is called Retrieval Augmented Generation. When a chat message is submitted, we first use Azure Cognitive Search to find documents that match the topic of the question. Then we pass this information along with the original question to GPT 3.5 to give the model more information to answer the question. Let's get started with a demo of what we're going to do today in this video. What I have up here is a collection of data formatted in JSON. This is going to be put into Azure Cognitive Search as the collection of data that I'd like my chatbot to refer to when it's answering questions. Now, I've formatted the data to have 5 fields per document. There's an ID. This is a unique identifier for the document. There's a department. This is the department in the company for which the document is relevant. There's a topic, which is a subcategory under the department. Then there's a body, which is the actual information in the document. And then there's an owner, the person who put the information and is responsible for the information into the document. So we have 7 examples here of data. There's a couple for the human resources department, which discusses health insurance, and there's a couple in the product department, which discusses our pizza and beverages. So when I actually go to do a demo, you should notice that it should be referring to this information when it answers the questions. Let's take a look at how this is going to work in reality. I'm going to ask a question about health insurance, and particularly coverage for a single person, and then what if I get married. So that's going to need the information from the first piece of information and this third piece of information. So let's run the demo and see if it can use this information. The first thing I'm going to ask is, when do I become eligible for health insurance? Now, this is a pretty specific question. If it didn't have my additional data, it wouldn't be able to answer this. So if I hit this question, notice it'll say, based on my knowledge, employees become eligible for health insurance after they've worked for the company for at least 1 year. For more information, I suggest contacting Joe Smith in Human Resources. So that's a good answer. This is exactly what I'd expect. How much would it cost is another question. It's free for a single employee, but if the employee has a spouse, it costs us $500 per month to cover the spouse, and a family plan is $700. And then it gives me some additional information, which is an interesting side effect sometimes of including more information in the search than is required. We can talk about this later. But it is generally answering the question correctly, based on my information. I'm going to ask a question about the product this time. So I'm going to say, what toppings can I get on my pizza? Now, there is information regarding the specific toppings that we sell. So let's see what this does. Based on my knowledge, it shows that the pizzas are made with these ingredients. Optional toppings include these other things. And what's also neat is it's actually suggesting you contact Jane Doe in the product department if you have further questions. So this is interesting. But now what if I try to ask a question that's outside the scope of the knowledge in my database? What was the result of World War II? Based on my knowledge, the result of World War II is not provided in the context provided. I don't allow the system to answer questions outside the scope of our knowledge base. The wording's a little bit strange, but that's something that you can tweak. The first thing we're going to need to do is set up our Azure Cognitive Search. So here I am at the Azure Cognitive Search configuration page. And the first thing we're going to need to do is create what's called an index. An index is the equivalent of a table in SQL Server, except it has more indexing for each field that make it more intelligent as far as searching. We're going to go ahead and make an index for the structure of data that I showed you before. So what I'm going to do is click Add Index. I'm going to give it a name, Knowledge Base. Now what you have to do is add fields. So the default's with giving you a field for the ID, which I'm going to leave. And there are options for what you can do with that field. Normally fields are retrievable, which just means you can look at that data. Filterable, sortable, and facetable, and searchable are the other options. I'm not going to go into the filtering, sorting, and facetable options, but in case I want that to do that, I'm going to check them off. And definitely click searchable. Now, you have to tell it what kind of field it is as far as how to index it. So there's an analyzer. The standard Lucene analyzer is a good one to use for simple fields, which I'm going to keep. I'm going to add another field called, this has to match my data, so let me take a look at my data. I have department, topic, body, and owner. So let me make department, which is going to be all of these things. Topic. Body. And owner. Now, it's good to do some research on these analyzers on your own. The standard Lucene is a good one. The other choice that I want to use for this project is the Microsoft English. For my body. This is where we're going to do most of the searches against to find relevant content. And this is tailored to the English language. From what I read, it seems like it does a better job than the standard Lucene model, but that obviously would take some analysis. Either way, pick analyzers for your fields that you think will work. And then when we're done, you'll hit create. Now I want to mention, make sure the case matches across everything we're going to do. I happen to have lowercase ID, capital D, T, B, and O for these fields. Case is going to matter in this code, so just keep everything uniform across all of the code and in here. So let me hit create. And we're ready to go. There's some secrets we need to get, which are over in the keys section in order to connect, but we'll get to that later. And also, I've created this index and there's no data in it. Now, there are a lot of mechanisms for bringing in data into your index. And if you go to data sources, you're actually able to add a data source that will pull the data from different places pretty much automatically. And I think you can even do it on a recurring basis. So you could pull data from a SQL database or any of these other types of locations automatically. But I'm not going to do that. I'm going to show you how to insert documents from code using this JSON file that I created. So that's all I want to show you in here. I created a utility program called Azure Cognitive Search Utility that will let us load this data from the JSON file into the index that I just created. If I go to the program.cs, I'll show you how it works. Basically, I include some libraries, the Azure Search Documents library. I also use the Microsoft Extensions configuration library because I want to load my secrets to connect to Azure Cognitive Search from my app settings.json file. So that's the first thing I do. I create a configuration builder with that file, and then I load the different variables that I need to give the API to connect to Azure Cognitive Services. So the first thing I do is I create this service endpoint, which will use this URL that's in the file, an Azure key credential with the key that I need to connect, and then it creates finally a search client. This is what actually does the work to connect to Azure Cognitive Search, to either add data or query the data. So the first thing I'm going to do is read all of the text from my knowledge base file. And that's what this does. This just reads everything from this file into a string. I use the JSON deserialize functionality in .NET to convert the JSON into objects. And I made an object for each row or each document. And here they are. It has my fields that we had before. Notice again the case sensitivity and matches what's in Cognitive Search, lowercase ID, capital D, T, B, and O. You also put these comments on these attributes, searchable fields. This is to tell the compiler that this is a Cognitive Search searchable field. So what we do next is we call this client upload documents async method with the list of objects that it deserialized from the JSON file. And what that's going to do is actually put those documents into the index. And then what I did after this is I just created a sample question just to see how the API worked against the data. So it creates the question in a string, provides some search options. In this case, the most important search option we're going to be using in this application is the size. This means it'll only retrieve 3 documents at most. It'll retrieve the 3 most relevant documents, or none if nothing's relevant, but up to 3. So then we click Search Async on the client object, and that's going to result in whatever results match the context of this question. So it actually sends this question string in and finds documents that are relevant. And I just loop through and print them out. Now let's run this and see this operate. So if I run it, okay, it must have successfully loaded my data because this question that I asked, which is about working 3 months ago, will my doctor visit be covered, did actually retrieve 3 relevant documents. It covered one that has the single employee plan, the other one about routine physicals, and another one about having to have worked for the company at least a year to get health insurance. So it would combine these 3 pieces of information later on to create a good answer, which we'll do actually in the chat application. But this proves that my load was successful and everything's working. Now let's go ahead and take a look at the chatbot application so we can see what changes I had to make to incorporate the Azure Cognitive Search functionality. All right, so the first thing I did was I added my secrets for connecting to Azure Cognitive Search into my app settings.json file. The other thing I did was add a knowledge base entry class. Now this class represents the actual index and the fields in the index. And this is very similar to the class I was using before in the utility that I just showed you. Again, it has a field for each of the fields in the index, and the case matches exactly. Now, if I go into chat service, this is where all of the main changes were made. The first thing I did was change the system message. And what it does now is it says, you are a knowledge-base driven chatbot. When you respond, do not mention the context of your answers. If you do not have context provided to answer your question, do not answer it. I wanted to make sure it wouldn't go off topic or answer questions that are not based on information from cognitive search. So I had to give it this instruction. Now the getResponse method is the one where most of the changes occurred. The first thing I do is I grab the last message off the message chain. This is the next question that's about to go into the GPT to be answered. And I'm going to want to augment that with the results of the search from Azure Cognitive Search. So I had to retrieve it first. So what I do is I first connect to Azure Cognitive Search, and that's what all of these lines here are. I do set my search options to retrieve 5 documents. You have to be careful here. If your documents are very large, you're not going to be able to include a lot of large documents into your ChatGPT request because there's a limit on the number of tokens that are allowed. So you need to make sure that your search produces small chunks of relevant information. So if you have large documents, it probably would make sense to break them up into subsections and upload those separately. Now, the first thing I do is I actually combine all of the questions in this thread of conversation in the message chain into one big string. This is because I want to search Azure Cognitive Search using this to find the articles that are relevant not only to the latest question, but all of the questions so far in the conversation chain. I found this was necessary in order to make sure that follow-up questions worked. The only downside to this is if the user starts going from one topic to another, it could produce too many or results that are not relevant. So it's advisable to make sure that your user sticks to a given topic. In fact, I might even consider finding a way to detect the topic, and if they start switching topics, clear the chat and start over. But I didn't do that yet. So if anyone wants to suggest ways to do that, feel free to leave a comment. But for now, the user could just clear their chat from topic to topic. So, okay, so all of the questions are combined together, and I search my Azure Cognitive Search using the search client's search async method. I have to pass the structure of the data of the documents in, which is my knowledge base entry class, all of the questions together converted to a string, and my search options, which will retrieve up to 5 documents. So this is going to give me up to 5 results based on the thread of conversation. So the augmented message I'm now going to create to send to ChatGPT is going to start off with a little bit of instruction. It's going to say, answer the question in the form of based on my knowledge. And this should be form. It was working anyway, but I'll add the M back in. Answer the question in the form of based on my knowledge. Then I actually append the current message. That's the question that I'm currently asking. And then I add based on the following knowledge. So it knows what knowledge to include. And this is where I go through and see what knowledge came back from Azure Cognitive Search. Now, it's possible that nothing came back. So if nothing came back, I append to the end of this GPT request, you have no knowledge. So that should be a trigger to it to not answer the question. But if there actually are results, I loop through them and I add each document's body to the end of the request. Now, I also did this. I don't add just the document body. I add a little bit of an extra bit of information. I say, for more information about this, contact and the document owner in the documents department. This is going to allow the GPT model to suggest someone they could contact if they have further questions about that topic. I separate all these with new lines just to make it clean. So that is the message that's going to get sent over. So now all I have to do now is submit that augmented message to the OpenAI client, which I discussed in the last video, and then it will produce a result. and it will return that result to the user. Let's go ahead and try this again, but before I do that, I'm going to put a breakpoint in this search results line because I want you to be able to see what comes back from Azure Cognitive Search. So let me run this. Now I'm going to ask a question about the pizza. So I'm going to ask, what is the pizza made out of? Okay. So you can see that the search results line is completed, search client is executed, and let me look at this results object. It retrieved 2 records, so it could have retrieved 5, but it only retrieved 2, and it retrieved 2 relevant records. So if I look at the first one, it's the one talking about the ingredients. That's the top result. So that's going to be the information it uses to answer the question. In addition to the second line, which is the fact that gluten-free pizza is also offered. So anything dealing with pizza was returned. So those 2 documents came back. Now if I hit continue, if it hasn't timed out, I should get an answer, which it did. And it structured a very good answer based on this. And it also included this information about contacting Jane Doe, who is in the product department, if you had any more questions. That's all for this video. Thanks again for watching Coding with Tom. If you have any questions, please add them to the comments. And also remember to click like, subscribe, and hit the notification bell if you enjoyed this video.